Let's practice graphing linear equations when they're written in standard form. For each of these linear equations, we're going to go ahead and identify the slope and then the y-intercept, as well as create a 5-point table and then make a rough sketch or a graph on a coordinate plane. For number 1, we have the equation 4x plus 2y is equal to 10. Just to get started here, I'm just going to go ahead and rewrite the equation before we get started working on it. And this is in standard form, which is that ax plus by equals c form. And we want to turn it into maybe slope-intercept form just to kind of get things rolling. And that way we can go ahead and identify the slope right away. So if we want slope-intercept form, we're going to go ahead and move everything to the other side so we can eventually get y alone. So we're going to go ahead and isolate y so we can get that y equals mx plus b form. Taking away 4x from both sides, we're going to get 2y is equal to negative 4x plus 10. Okay, at this point we're a little bit closer to getting what we want. We just need the coefficient for y to be 1 instead of 2. So let's go ahead and divide everything by 2 here. On the left side, 2 divided by 2 is just 1 or 1y. Y is equal to, and then negative 4, this negative 4 divided by positive 2, that's going to be a negative 2, so a negative 2x. And then if we have this positive 10 over positive 2, 10 divided by 2 is a positive 5. All right, so this right here is our slope-intercept form. So when we're identifying our slope here, the slope is going to be this negative 2. So I'm going to go ahead and write up here that m, or the slope, is equal to negative 2. And you can think about that as a ratio of negative 2 to positive 1, or you can think about that as a positive 2 to a negative 1, right? Either way is going to be fine. And then for the y-intercept, let's go ahead and see what that's going to be. Now the y-intercept is this positive 5 at the end here. So the y-intercept, or b, right, that's equal to 5. And what that tells us is that we're going to have the point 0, 5. So if that helps you kind of refresh your memory on what the b represents, that's always going to give you that free point on the graph along the y-axis. Now that we have our slope and our y-intercept, let's go ahead and make a 5-point table. All right, so here we have our xy table. We know we have this point of 0, 5. That's kind of our free point we got from the y-intercept, or that b number. And then we can just go ahead and put some numbers that are smaller, like maybe negative 1 and negative 2 going in this direction. And then we can put some numbers like positive 1 and positive 2 in this direction, okay? So let's go ahead and plug these x values in to find out each of these y values that correspond with them. So x is negative 2 here. So we're going to say y is equal to negative 2 multiplied by negative 2 plus 5. Negative 2 times negative 2 is positive 4. Positive 4 plus 5 is going to be positive 9. So when x is negative 2, y is positive 9. All right, so we'll put that right here. Next, we're going to say, okay, now x is negative 1. So let's change this x to negative 1 now. So we're going to say y is equal to negative 2 times negative 1 plus 5. Negative 2 times negative 1 is positive 2. Positive 2 plus 5, that's going to equal positive 7. Let's go ahead and put that in our table here. All right, and we can go ahead and say, okay, what if x is positive 1? We can go ahead and plug in 1 over here. Y is equal to negative 2 times positive 1 plus 5. Negative 2 times 1 is going to be negative 2 plus 5. That's going to equal positive 3. So when x is 1, y is positive 3. Finally, when x is equal to this positive 2, let's go ahead and plug it in here. So it's going to be y is equal to this negative 2 times positive 2 plus 5. Negative 2 times positive 2 is negative 4. And negative 4 plus 5, that's equal to positive 1. So when x is positive 2, y is equal to positive 1. And hopefully if you're looking at this pattern here, we can see that these are all falling by 2 each time, while these are increasing by 1. So you can notice here that it's falling 2 while these are increasing by 1. So a ratio of negative 2 to positive 1 matches our slope of negative 2 to positive 1. All right, now we're going to go ahead and make a rough sketch of the graph here. All right, now just to make it a real rough sketch, I'm not even going to use grid lines here. So for negative 2, 9, that's going to be 2 to the left and then 9 up. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So negative 2, 9 is going to be somewhere up here. Okay, I'm just going to put a dot roughly there. And then negative 1, 7 is going to be roughly here. Okay, that's 1 to the left and then 7 up. Then 0, 5, I'm going to try to use that bluish looking dot just to show you that y-intercept. And then 1, 3, we're going to go 1 to the right and then we're going to go 3 up. So 1, 2, 3. And then finally we have 2, 1, so we're going to move over 2, and then we're going to go up 1. So if we go ahead and connect these points here, this should give us a rough sketch. So again, it's not perfect, but it is in the general vicinity, just kind of a rough sketch here. Okay, so this would be the linear equation that represents this equation. Here's number 2. For number 2, we have the equation 3x plus 4y is equal to 24. So just getting started here, let's just copy down the equation. So we have 3x plus 4y is equal to 24. This is in standard form, and if we're going to go ahead and graph this, it's kind of nice if we can just turn this into slope-intercept form. So let's isolate that y the best we can. We're going to start by taking away 3x from both sides of the equation. If we go ahead and do so, we're going to get 4y is equal to negative 3x plus 24. And then we're going to go ahead and divide everything by 4 here, just so we can get the coefficient of y to be 1. 4 divided by 4 is 1y, so we're going to y is equal to negative 3/4 x, because that's negative 3 divided by positive 4, and then 24 divided by 4 is going to equal positive 6. All right, so there's going to be our equation in slope-intercept form. And if you take a look at this coefficient for x, this negative 3/4, that's the slope. So we can either consider this slope of negative 3/4, we can look at it 2 different ways. We can say that is negative 3 over positive 4, or we can look at it as positive 3 over negative 4, right? Both of those are fine to think about it that way. And then we have this plus 6. Remember, that's our b value. So b is always that constant. That's going to be positive 6. So we know that on this graph that 0, 6 is going to be a point that's going to exist. Now let's go ahead and make a table. All right, so we have an XY table here, and we're going to go ahead and throw our 0, 6 right in the middle, just because we already have that as a free point. Now notice how we have a denominator of 4 for our slope, so it's in our best interest to use multiples of 4. So I'm going to use negative 4 and negative 8, and I'm going to use positive 4 and positive 8, just so we can have some nice cross canceling. Okay, let's go ahead and take this x equals negative 8, and let's substitute that in right here to solve for y. So y is going to equal negative 3/4 times negative 8. That's negative 8 over 1. And then we're going to add 6. Good thing we chose multiples of 4 because these will cross cancel. So that's going to be a 1 and a negative 2. So negative 3 times negative 2, that's going to be positive 6. So we're going to have 6 plus 6 here. And that's going to equal positive 12. All right, so when x is negative 8, y will equal positive 12. Go ahead and put that in over here. Now when x is equal to negative 4, let's substitute that in where x is and solve for y. So y is equal to negative 3/4 multiplied by negative 4 over 1, and we're going to add 6. These 4s can cross cancel, we're left with a negative 1. Negative 3 times negative 1 is going to be positive 3, and positive 3 plus 6 is equal to positive 9. So when x is negative 4, y is positive 9. Next, we're going to try when x is 4. We're going to substitute that in. So we're going to have y is equal to negative 3/4 multiplied by 4, or 4 over 1, and then add 6. These 4s will cross cancel to make 1s. Negative 3 times 1 is negative 3, plus 6, that's going to equal positive 3. So when x is positive 4, y is equal to positive 3. Finally, when x is equal to 8, we can substitute that in right here. So we're going to get y is equal to negative 3/4 multiplied by 8, or 8 over 1, and then add 6. This 4 and 8 cross cancel to make 1 and 2. Negative 3 times 2 is going to be negative 6, and negative 6 plus 6 is equal to 0. So when x is 8, y is 0. All right, now that we have a table, let's go ahead and sketch a graph. All right, so we have our x and our y axis here, and then if we're going to go ahead and plot some values here, let's go 1, 2, 3, 4, 5, 6, 7, 8 along the negative x-axis, and then let's go up 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right, so this negative 8 comma 12 is going to look maybe something up here, roughly. Okay, and then we have negative 4 comma 9, so move over to the left 4 and then go up to 9, maybe something like here. And then we have 0 comma 6, so I think that's going to be right about here. It's going to be along the y-axis. Then we have 4, 3, so let's move over 1, 2, maybe 3, 4, and then go up 3. So 4, and then 1, 2, 3. And then over to 8, 4, 5, 6, 7, 8. And let's plot one more point, 8, 0. That looks like an x-intercept. And so if we go ahead and see, hopefully these dots make pretty smooth line. No, not very smooth. My spacing might have not been the greatest here. So again, it's a rough sketch, so hopefully you kind of get the gist here. I think my spacing was just a little bit off, but hopefully you can kind of see that if we had a nice, more accurate graph, this will be right where we need it to be. Here's number 3. For number 3, we have 5x plus 3y equals 45. So I'm just going to go ahead and copy that equation down. All right, and let's go ahead and turn it into slope-intercept form. So let's go ahead and take away 5x, take away 5x. We want those to be on the other side of the equation. If we do that, we're going to be left with 3y is equal to negative 5x plus 45. And then to get y completely alone, or to have a coefficient of 1, we're going to go ahead and divide everything by 3. So 3y divided by 3 is just going to be y. And then negative 5 divided by 3 is going to be negative 5/3. And we'll put that as x next to it. And then 45 divided by 3 is going to be 15. All right, so our slope is going to be negative 5 over 3. So we're going to say m here is equal to negative 5 over 3, which we can also think of as negative 5 over positive 3, or we can think about that as a positive 5 over a negative 3. They're both fine. And then this positive 15, what that really means is we have a b value of positive 15, and that gives us a point on our graph, and that's going to be 0, 15. Now let's make a table. Here we have a 5-point table. We're going to use our free point of 0, 15 and put it right in the middle. And we could choose 2 numbers smaller, 2 numbers bigger, but let's be intentional about this. So this is a 3, so we'd like things to cross cancel. So I'm going to go ahead and use negative 3 and negative 6. So these are all 3 below and then 6 below. Let's go 3 above and then 3 more above. So these will help us get whole number values for our y values as well. All right, let's see what y is equal to when x is negative 6. Plugging that in, we're going to get y is equal to negative 5/3 multiplied by negative 6. So it's negative 6 over 1. Plus 15. This 3 and negative 6 will cross cancel. We'll have 1 and negative 2. Negative 5 times negative 2 is going to be positive 10. 10 plus 15, that's going to equal 25. All right, so I'm going to go ahead and write that over here, but we're going to say y is equal to 25 when x is negative 6. So let's go ahead and put that positive 25 right there. Now, what if x is negative 3? Let's go ahead and plug in x equals negative 3 here. So that's going to be y is equal to negative 5 over 3 multiplied by negative 3 over 1 plus 15. These 3's will cross cancel. We have 1 and negative 1. Negative 5 times negative 1 is going to be positive 5. And 5 plus 15, that's going to equal positive 20. So when x is negative 3, y is 20. All right. Next we have x is equal to 3. So we see x is 3 here. Let's go ahead and substitute that in. So y is equal to negative 5 over 3 times 3 over 1 plus 15. Now these 3's are going to cross cancel to make 1's. Negative 5 times 1 is negative 5 plus 15. Negative 5 plus 15 is equal to positive 10. So when x is 3, y is 10. Let's go ahead and put that in the table. And then finally we have x equals 6. Let's substitute that in. So we're going to say y is equal to negative 5 over 3 times 6 over 1 plus 15. And the 3 and the 6 will cross cancel, so we get 1 and 2. Negative 5 times 2 is negative 10. Negative 10 plus 15 will equal positive 5. So when x is 6, y is 5. All right, cool. Now we have we've filled out this table together. All right, my graph is going to be even rougher here, so if you have graph paper, great. But I'm gonna try to just do a real quick estimate. So let's see, I think what I'm gonna do first is I'm gonna draw my line first, and then I'm gonna estimate my points alongside it afterwards, which I know is totally backwards, but I'm not going to draw them too specific here. Okay, so the first one that I'm gonna put on here is going to be this y-intercept, right? This 0, 15. I'm going to put that right here because I know that's going to be the y-intercept. And then let's go ahead and see what other dots are on here. Or we have like -625. That's going to be this one right here. -6, 25. And then -3, 20 should just be halfway between those two. So I'm going to put that here, just where it should be. And then we have 3, 10. That's this one here, 3, 10. I'm going to put that right over here. And then we have 6, 5, right? 6, 5. I'm going to put that right over here. So again, I know these aren't perfect, but let's imagine we made this to scale and that these are where those points would be. Obviously, if we had graph paper, this would be a lot easier, but I think the rough estimates are okay. All right, let's try number 4. For number 4, we have the equation 5x plus 4y equals 40. So let's go ahead and get this going here. Let's copy it down, and then let's start rearranging so we can get y alone. If you'd like to pause and give it a try on your own, feel free to do so. Give it a try if you're feeling pretty good about it. I'm going to go ahead and take away 5x's from both sides here. And then if we do that, we're going to get 4y's equal to -5x plus 40. And then we need to get y alone, so let's divide by 4 and then divide by 4. So 4 divided by 4 is 1, or 1y. -5 divided by 4 is going to be -5/4 x, and then 40 divided by 4 is going to be 10. All right, so this is a much easier to graph from. This -5 over 4, I'm going to go ahead and say that's their slope. So m equals -5/4. Okay. You could also think about it as a -5 over a +4, or you can think about it as a +5 over a -4. Okay. And then this +10, so far it seems like all our y-intercepts have been positive, so b is equal to 10. And then we can go ahead and say that's going to be 0, 10 for the y-intercept. Okay, let's go ahead and make a table now. So our free point here is going to be that 0, 10, so I'm going to put that in the middle. Now, let's be strategic again. So we have 4 in the denominator, so let's go with multiples of 4, so -4, -8. And let's go with +4 and +8. Okay, now let's go and fill in this table a little quicker than we were before. So notice how these values are going up by 4 every single time. And if you see that, that's corresponding to these x values going up by 4. That means the y values must be going down by 5. All right, so if we know that pattern, then we can go ahead and say that this must be 5 and this must be 0, right? Because they must be going down by 5, and so this must be 15 and 20 because they got to be going up. Okay, so remember our slope we can use, so we're going to try to do this a little bit quicker using the slope instead of doing all that algebra and solving the equations. Okay, so right away we're going to go ahead and fill in. This is going to be 15. This is going to be 20. Okay, this is going to be 5. And then this is going to be 0. Again, we know that because we are increasing by 4, plus 4, plus 4, plus 4. This must be -5, -5, -5, -5. Just because we knew the ratio of the slope. Okay, so that hopefully will make your life a little bit easier. Again, for this graph, I'm going to make another rough sketch here. Okay, so let's go ahead and do something along the lines of this. And I'm going to go ahead and throw some arrows on this. So I'm going to start with the 0, 10 because it's easiest. That's along the y-axis. Okay, and then moving over to this -8, 20. That's maybe something like here. Okay, it's got to be in quadrant 2. And then for -4, 15, I think that's somewhere right around here. And then for 4, 5, maybe that's somewhere right around here. And then 8, 0, that one works out pretty nicely because it's got to be on the x-axis. It's the x-intercept. And so that would be right over here. So these are some rough estimates for these points. For number 5, we have 8x plus 6y is equal to 24. So let's go ahead and write that and then see what we can do with it. Okay, so first I'm going to go ahead and get rid of these 8x's on the left side, move it to the right side. So let's take them away. If we go ahead and do that, we should be able to see that we have 6y is equal to -8x plus 24. Then to get y isolated, we can divide everything by 6. If we do that, 6 divided by 6 is 1, so we have 1y. -8 over 6 is going to be -4 over 3, if you just divide them by their GCF of 2. And then 24 divided by 6 is equal to 4. Now we have it in slope-intercept form. So we have identified our slope here. So we can say m is equal to negative 4 over 3. We can also say that's going to be positive 4 over negative 3. Or we can say this is negative 4 over positive 3. Both versions are okay. And then this positive 4 is going to be our b value. So b is equal to 4, which means that we know we have the point 0, 4. All right, let's make a table. Here's our table. We're going to put 0, 4 right in the middle. And then we're going to go ahead and pick some numbers that are multiples of 3. So let's go with negative 3 and negative 6, then positive 3 and positive 6. Now notice that these numbers here are increasing by 3 each time. So if we go ahead and use this ratio over here that's increasing by 3, then our y value should be decreasing by 4. Okay, so let's go ahead and put this number in as 0 and negative 4. That's decreasing by 4, and then we can say 8 and then 12. That's going to be increasing by 4. Okay, if you're not sure about that, feel free to go ahead and plug in each x value to confirm that these are the correct y values, but I promise that they are indeed correct. All right, now for a quick graph. Let's see here. We have a slope that's, I guess, a little on the steeper side, but not too steep. Let's go ahead and maybe do something like, maybe something like here. Okay, and then let's kind of work around this one the best we can. And so we will start with this 0, 4. I'm going to plot that one right here along the y-axis. And then let's see, we have this negative 6, 12. So let's see here. Maybe I'll put that right around here, roughly. And then we have negative 3, 8. That's got to be halfway in between. And then we have 3, 0. So that's going to be here. And then we have 6, negative 4, which must be somewhere around here, I'm guessing. Okay, it's got to be in quadrant 4. So there's a rough sketch of the graph. For number 6, let's see what we got. We have 6x plus 9y is equal to negative 36. Then we can go ahead and solve for y. So let's take away 6x from both sides here. If we do that, we're going to have 9y is equal to negative 6x minus 36. Then we can go ahead and divide both sides by 9. And then we're going to get 1y, or just y. Negative 6 over 9 is, if we simplify that, it's going to be negative 2/3 x. And then negative 36 divided by positive 9 is going to be negative 4. Our slope here is going to be negative 2/3. So we can say m is equal to negative 2/3, which can be thought of as negative 2 over positive 3, or also as positive 2 over negative 3, whichever way you want to think about it. And then our b value, our y-intercept, I think this is the first one where it's been negative on this set of practice problems. So b is negative 4. All that means is our y-intercept is below the x-axis. So I'm going to go ahead and write 0, negative 4. Now let's make a table. Alrighty, our free point we got here was 0, negative 4. Looks like we have a denominator of 3, so I'm going to go ahead and go by multiples of 3. So negative 3, negative 6, positive 3, positive 6. Okay. Now if you notice here that these values are going up by 3, all right, so the change of x is going up by 3. So again, change of x is always going to be on the bottom. So that means the change of y has got to be minus 2. So the y values have to be decreasing by 2. So this must be negative 6 going down by 2, then negative 8. And if we increase by 2, that would be negative 2 and then 0. So these would be the values for our table. And again, if you want to plug in your x values and do the algebra, you can do that as well. All right, so we got our x-axis here and our y-axis. And then if we go ahead and make a graph, it's going to look something a little different than the past couple. So I'm thinking maybe something along the lines of this. I think it's crossing on a negative part as opposed to the positive part. So something I think like this would be pretty accurate. So maybe here would be this y-intercept, that's a 0, negative 4. Again, it's below the x-axis, okay? Then this negative 6, 0, that must be the x-intercept because it has a y value of 0. Then for negative 3, negative 2, that's going to be just about here, I think. It looks pretty accurate to me. And then 3, negative 6, that should be somewhere around here in quadrant 4. And then 6, negative 8 should be even further in quadrant 4, maybe something like right here. All right, so there's a rough sketch. All right, let's take a look at number 7. For number 7, we have 12x. Let's go ahead and copy this as I say it. 12x minus 16y is equal to 48. Let's go ahead and get y alone. So let's go ahead and subtract this 12x from both sides. That will get it to the other side for us. Those will go away, so we're left with negative 16y is equal to negative 12x plus 48. Okay, then we're going to go ahead and divide everything by negative 16. Divide by negative 16. So we're going to get y is equal to, and 16 and 12, they can both divide by negative 4. So that's going to be positive 3/4 x. And then 48 divided by negative 16 is going to be negative 3. All right, so if you need to pause to think about that, feel free to do so. But it looks like we have a positive slope here. So I'm going to write m is equal to 3/4, right? Or you can think about that as a negative 3 over a negative 4 if you would like. Or you can think about that as a positive 3 over a positive 4. That's perfectly fine. And then we have a b value of negative 3. So if b is negative 3, then we know our point here is going to be 0, negative 3. That would be a free point. Now for a table. Here is our 5-point table. We can put 0, negative 3 right in the middle. Then we have a denominator of 4, so let's go ahead and use multiples of 4 here. So I'll go negative 4, negative 8, positive 4, positive 8. And let's go ahead and use those values and see if we can figure out what the y values would be. Now let's skip the algebra a little bit here and see, okay, these are going up by 4, so these are increasing by 4. So if these are increasing by 4, then the y value should be increasing by 3. Okay, so if we increase by 3, this would be 0, and then this would be 3. Then if we go up the graph, this should be decreasing by 3, so negative 6 and negative 9. Okay, again, if you want to do the algebra just to confirm a couple of these, if it still feels a little strange, feel free to do so. Now let's make a graph. Alright, so here we have an XY graph, and let's see if we can make a graph that looks somewhat the way it is supposed to. So let's go ahead and make a diagonal line. It's got to have a positive slope this time, but it's going to be somewhat gradual. So I'm going to do maybe something along the lines of this. Again, if the slope is 3/4, it's doing less rising and a little bit more running. It's got a y-intercept of negative 3, so that's going to be this point right over here. And let's go ahead and see. Okay, we have negative 8, negative 9. So I think that might be somewhere down here like this. Then negative 4, negative 6 might be somewhere in between like here. Then 4, 0 is going to be right along the x-axis. And then 8, 3 is going to be somewhere along the lines of here, more to the right and a little bit up in quadrant 1. Okay, so there's a rough sketch there. For number 8, we have 8x plus 12y is equal to negative 60. Now let's go ahead and get y alone. So let's take away 8x and take away 8x. If we go ahead and do so, those 8x's will cancel out. We're left with 12y is equal to negative 8x minus 60. Then we need y alone, so let's go ahead and divide by 12 and divide by 12. 12 divided by 12 is 1, so we have 1y equals. 8 and 12 can both divide by 4, so that's going to be negative 2/3 x. And then 60 over 12 is going to be 5, so it's going to be negative 5. Now we have this negative 2/3, that's going to be our slope. So we're going to say m can be thought of as a ratio of negative 2/3. Or to make it more specific, we can say negative 2 over positive 3. Or we can say positive 2 over negative 3. And they all are different versions of the same thing. And then we know our b value is negative 5. So we say b is negative 5. That can be thought of as a point of 0, negative 5. Now let's make a table. All right, we got our XY table. We can throw in our free point of 0, negative 5 right in the middle. Now we see our denominator for our slope is 3, so to cross cancel, let's use multiples of 3. So I'm going to go down 3 and down 3 again. Then I'm going to go up 3 and then up 3 again. Now, if you notice here that these values are increasing by 3 as we go down, then we must do something different with the y values. So we're going, let's see here, up 3 with the x values, so we must be going down 2 with the y values. So down 2, this should be -7 and -9 if we keep going down by 2. And this would be going up by 2 and another up by 2. So we have -1, -3, -5, -7, -9. Now that we have a table, let's sketch a quick graph. Here's our x-axis and here's our y-axis. Maybe our graph will look something along the lines of this. Maybe it could be a little bit more gradual, something along the lines of that maybe. Go ahead and throw some arrows on here. And then for the 0, -5, that should be right along the y-axis, so something right there is good. And then let's see what else we got here. So we have -6, -1, so -6, -1 might be somewhere pretty close to the x-axis right there. Then we have -3, -3. Let's put that right over here. Then we have 3, -7. That's going to be somewhere down here in quadrant 4. And then finally we have this 6, -9, so that's going to be just a little bit further down. All right, so here's a rough sketch. So there you have 8 different practice problems on graphing some linear equations when they're written in standard form. So again, for each of them, we just rearrange them. So we turn the standard form into slope-intercept form, or y = mx + b. And if we have the slope and the y-intercept, that helps us kind of get started with making a table and then plotting some points and making a graph. So if you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.